Hi, this is Stan again. So for those of you who just saw the last video, we talked about how to initialize CocoaPods within the corporate network. If you haven't watched that video and followed along, it would probably be best if you did. That will really help speed up the bootstrapping of this project. If not, and you've created a project and you've dragged and dropped the libraries from the SDK into your project, that's fine. As we add this template code into the application, go ahead and pull that from the repository in the description below, and just drag and drop those into the application, and you should be at the same point. But in any case, so I'm going to go forward as if we're all using CocoaPods on this one. And the pod file here already has the iOS SDK linked. So I'm going to add some additional code that I've been creating over the past several months with some of the colleagues here. It's just called STS initials OData no SDK. And so this code, it's not a standard product framework, but it is, I think, some best practice usage of the SDK. And I've already done a lot of the bootstrapping that you would need to do anyway within your application. So this, I think, will really help kind of speed the development and get you started without going too far into the application. Okay, so this pod file has been updated. So let's go ahead and add the new pod. So I'm actually going to hit pod update. Whoops. And it's again going to check the dependencies. Yeah. So you'll see it goes through, it says, okay, so I've already got this right version of iOS SDK, and I'm going to add this new STSOData. And if we look down at the contents of STSOData, it's not very large. And really what I've done here is implemented some of the standard application components that are necessary in the SDK. So you'll see here I have an online store, which is a concrete implementation of the SOData online store and its respective protocols. An offline store also. And I've added, and really just kind of the overall premise around this framework is to enable blocks, again, kind of around some of the delegate interfaces also. So I have some high-level block interfaces as well. So very simply, we have a version of the online and offline store that are both block enabled. I have what's called the logon handler, and this is kind of a core component of the application that handles all the MAF logon delegate stuff, handles getting your connection settings and setting up the networking for the application under the covers. It basically hides all this stuff. There's not very much that you're going to need to do with it. I've also gone through and created default implementations of the usage, and usage is not logging per se. Usage is actually an API that allows you to capture timers within the application and log information about how the end user is using your application. The usage APIs are only being really executed for and uploaded for applications that are running against HANA Cloud Platform mobile services, because we're using HANA database there. But they're implemented here as a category on the logon handler. The same for the logging. So this actually is kind of debug and help desk style logging, and these logs are uploaded through either an on-premise or a HANA Cloud admin interface, and eventually onto a solution manager. End-to-end trace is the same. So these are all just kind of category or wrapper methods, so to speak, around the logon handler. Okay. And then the data controller. So the life cycle of creating the data store And we'll go into more detail on the data store later. But the life cycle around creating it, deciding whether or not you're working in online mode or offline mode, and then actually having, again, a block interface for sending network requests or reading from the local database. All this stuff has been encapsulated in this data controller implementation. And this really kind of makes your life easier, I think. The create, update, delete has also been implemented as categories on data controller. These are going to be absolutely model generic or model agnostic, so to speak. So the update, delete, and create doesn't matter what collection you're in. Obviously on create we actually specify a collection, but for update and delete these are just generic. So you should never have to touch this as a developer. The fetch requests, this is interesting. So as part of this model, and in a moment I'll show you, I'll actually ask that you implement your fetch requests as a category on data controller. So I've provided a sample of this, a fetch bookings with expand, fetch travel agencies, and then some example implementations. So this is an example of the fetch travel agencies. And so you can just copy and paste this code into your own code in a moment. And this will get you right out the door. Okay, so actually getting the application off the ground. So this is pretty straightforward. So this is designed so that there's really a minimum of framework-specific stuff that you need to be aware of. So in your app delegate, your app delegate's really the core of the application. So we're going to create a logon handler here. And this is going to be a singleton. We're going to create a data controller also. And this will also be a singleton. If you are developing with the offline capabilities, and when we say offline in this case, we're talking about a client-side database. It's called Mobile Link, and it has this really optimized synchronization protocol. And as part of your development and bootstrapping process, you tell Mobile Link for these collections and these collections only, or even these collections with these query filters only, I want to store that data in the database, and all of my reads, writes, updates will go to the database, and then the synchronization to the server will be handled through another procedure. If I make a request, an OData request, that is not within the universe of those filters, they're going to go over the network anyway. But it all goes through the same APIs. So if you are using that type of offline store, then you'll need to always, in did finish launching with options, use a global init, and then in will terminate, use a global finish. Okay. So we'll terminate. I will add that here. SOData offline store global fin. Okay, so the important method here in app delegate is application did become active. Okay, so there's two things that we're going to do here. The most basic, we'll do that first, is on the logon handler shared. There's a property called logon manager, and we're going to call logon. And that's going to handle all of the registration against whatever server you're putting this at, whether it's an on-premise, on a cloud. If you have the right properties, you can skip those and even go straight to a gateway, although you lose, obviously, some functionality there. Logon manager, logon. Very simple. Okay, so the other things, and we're actually going to do an offline development case here. So let's specify a working mode for the data controller, either online or offline. So say data controller shared, working mode equals working mode offline. And let's also since we're working in offline mode, as I said, we need to specify some defining requests. Okay, so defining requests are actually not fully qualified URLs. They're just resources. Okay, so I'm going to say, let me actually just copy a couple defining requests into the app. We could even just start with one first and then get into an array. First off, let's just get the travel agencies. So what we'll say here is all of our travel agencies will be offline. Okay? And so let's go in and say data controller, shared, defining requests equals the array of k defining request 1. And that is everything that we need to do in, there we go, in the app delegate. So it's very clean, very light touch. These are the important things that you need to touch. Okay. So now let's talk about how we get data. Okay. And what I'm going to introduce here is a concept that's very consistent with MVC. And the premises, kind of are as follows, that I don't want to be making network requests directly from my view controllers. That's really the fundamental concept that's important here, because that allows me to decouple my model lifecycle, getting data, updating data, from my navigation hierarchy. So as I'm navigating through my application, I want to be able to do so very responsively. I want to be able to load my UI independently of the model and then populate the UI as the model updates. So I want my UI to be responsive to the end user and reactive to changes to the model. So we're going to accomplish this in one of any number of ways. In this example, we're going to use standard iOS KVO. Another thing that I would recommend, and which is really naturally enabled through using CocoaPods here, is a third-party library called Reactive Cocoa. Is just some rock star quality code that wraps KVO and yeah, I mean it's a fairly complicated library, and it gives you everything from promises to the ability to use functional programming really to set the property values in your UI to the future responses of blocks is kind of the high level bit. So that means that I can load my UI instantly, and then as the model updates, everything is very quickly updated. It also allows me in some cases, and I can hopefully do a video on this in the future, to change values of controllers from changes to the UI. So I can do kind of bidirectional data binding. It's a concept that we really don't have in iOS. It kind of comes out of the Windows development framework. So we're going to use KVO for the model. So what I'm going to do is I'm actually going to add two new files. One is just going to be an NS object, and for simplicity's sake, I'm going to call it model. And you can call it whatever you want, but just so that we're all aware of what we're working with. The other thing I'm going to do is I'm going to create a category on, oops, going to create an Objective-C file. They switched around the navigation here. I'm going to create what's called fetch requests as a category on data controller. And it's important, keep this in your application. Don't try to put this in the pod, because the pods will be wiped out if you update them in the future. But the concept behind this fetch request is very simple. Your data controller contains the core of your networking. Your create, update, delete requests are already implemented there. So you can actually create your application's fetch requests in a similar manner, go ahead and just copy and paste some of the sample code here from the fetch request sample, and it really gets you out the door immediately. And we are then going to, let's create our first properties then. So we are already specified that we're going to offline the travel agencies collection because we told the data controller that one of our defining requests for the offline store would be travel agencies collection. So let's create a property here called travel agencies. Okay, so there is a template for model where we want model to be a singleton. You could treat it as, you could create one and create it as set it as a child of your app delegate. That would be simple enough. What I prefer to do is create a singleton, and the method for that, I could just copy it out of my data controller really. And I like to do this actually quite a lot. Nearly all my major controller components become singletons. Let me just copy this into model, and obviously this is going to be a shared model, and say travel agencies is an array. So now what happens is when I call the shared, it does a dispatch once to create and init the model, so now I have the agencies. So as I add properties to my model, best practice would be to actually initialize them as empty arrays within the init. And then I'm going to go into the data controller fetch requests and create a method called fetch travel agencies. And the implementation of this, I can actually, as I said, just copy and paste from the fetch travel agencies sample. So let me take a moment to look at what's happening here. So I'm specifying the resource path of the collection, and as you remember, it maps to the defining request. And then on the data controller, I'm scheduling that request, and I'm saying it's a read, and for the reads I don't need an entity, and when it completes, I'm getting back the array of entities, and I'm getting back an object, an id called SOData request execution. And there's a whole bunch of information here, including both the original request, the base response, and the entire structure of that response. So if I needed to do something more complicated than just parsing out the entities, or just touching the entities, I could do so here, or I get the error. So if I get the entities back, because this completion block is going to be called, so when it's called, I have access to these parameters, right? So if I have entities, then I'm actually going to I'm going to change this from data controller to model. And the reason that this isn't done natively within the pod is that I don't know what you want to call model. If you want to call model controller, if you want to call it my model, if you want to have multiple models, I didn't want to standardize on that. So actually import model, and we're going to specify a set. We're going to set the travel agencies to entities. There we go. And let me go ahead and run. Should be happy, so let me pull that over here. And what I'm actually getting here is just the standard logon. So let me connect to a server. We haven't mapped the model to our UI yet, but let's prepare it for it. So let's say SMP QA 1201. Password welcome. And we could go ahead and, yeah, let's use secured 443. And you can see the registration is complete if you end up at this app passcode. And you can see the registration comes in. Here's a whole bunch of app settings that are available. I'm going to skip the app passcode. I don't need it. And we're good to go. Okay, so I'm going to pause the video so that it doesn't get too long, and we'll come back and we'll bind this response to the UI.